Hi everyone, I am Chia Wei. I am here to present KIB 1003 about chapter of friction. So, what is friction? Friction is the force resisting the relative motion of solid surface, fluid layers, and material elements sliding against each other. The resistance of one surface or object encountered when moving over another. There are five types of friction, which are dry friction, fluid friction, lubricated friction, skin friction, and internal friction. In this topic, I will focusing on dry friction. Dry friction is the force opposed the relative lateral motion of two solid surfaces in contact. Dry friction can be divided to two types, which are static friction and kinetic friction. From this picture, we see a block was put on the surface and the force reacting on the block is W and also N, the normal force. When you apply a force at here, there will also a force against the force we applied. So the force against is the friction force. Static friction is the force between two surfaces that prevent those surfaces from sliding or slipping across each other. The formula we can use is Fs equal to mu Sn, which Fs is the static friction force, mu s is the coefficient of static friction, and N is the normal force. To keep the object to remain stationary, if we increase the force applied, the static friction force will increase until its maximum static friction force, which Fm. According to this graph, when we increase the force, the static friction force will increase. Then the object will start to moving, and this motion we call it impending motion. And then the friction force will turn to kinetic friction force, which will always oppose the sliding motion and tries to reduce the speed at which the surface slide across each other. The further increase of force applied will cause the block begin to move as the F drop to a smaller kinetic friction force. The formula we can use is Fk equal to mu k, which Fk is the kinetic static force, mu k is the coefficient of kinetic force, and N is the normal force. Mu k is almost of 0.75 of mu s, so mu s is greater than mu k. Here is the example to let us more understand about friction. Here is the example on the smooth surface, and this is the example from the rough surface. From this example, we can see that the angle of the first surface, which is smooth surface, is smaller than the angle at the rough surface. From the example of just now, why it will like that? So here I draw the free body diagram for the sharpener on the surface. So W is the weight of the sharpener, and then N is the normal force, F is the friction force. So the W will resolve to the X component and Y component. So for the Y component, the formula is mg cos theta, and the X component is mg sin theta. At first, the object will remain stationary when the angle was increased. After a few seconds, the object sliding at a certain angle of declination. This is because when we increase the angle, the force mg sin theta will increase until it exceeds the maximum friction static force. After the mg sin theta exceeds the maximum static friction force, the object will sliding down. When the object was sliding down, it has kinetic static force, but it is smaller than the static friction force. The conclusion that we can make from just now example is the smoother surface has a smaller friction force compared to the rough surface. So the Fs of rough surface is greater than Fs of smooth surface. So more downward force required by rough surface to exit the friction force, so the tilted angle needed is also greater. That's all from me. Thank you.